So this is 5.7a, elementary algebra, division with polynomials. Alright, so we are going to start out really elementary with you for this, because this section here, either you've never done this before or it's been so long that it's probably going to be a little bit of a challenge for you. So I'm just going to take them in little baby steps and we'll see if we can make this as simple as possible for each of you. Example 1 says divide 10x cubed minus 15x squared by is the line, 5x. Alright, so the book has a way of doing this. It's a little bit different than what I do it. And so let's look at the way I've always found it easier. When you have two parts to a numerator, meaning separated by a plus or a minus sign, two terms here, and the whole thing is over 5x, I split each one up. So I write this over 5x minus this over 5x. So I get 10x cubed over 5x okay, because this problem here says that everything over this, everything up here in the numerator is over 5x. So if you split them up, you have to split them up. You put each term over the 5x. Alright, so now I just look at this here. What is 10 over 5? 10 over 5 is 2. If I have 1x here and I have 3 here, well, I'm going to cancel out this one. I'm going to cancel one of those, leaving me with 2. 15 over 5 is 3. I've got 1x here, I've got 2x here, so I'm going to get rid of 1 here, I'm going to get rid of 1 there, leaving me with an x. Okay, and I'm done. So, let's look at example 2. It gives me 3x squared minus 6 over 3. So again, I'm going to split them up. 3x squared over 3 minus 6 over 3. So 3 over 3 is 1, so I can cancel those, leaving me with x squared. What's 6 over 3? 2, and you're done. So example 3 says, find the quotient of 27x cubed minus 9x squared and 3x, or divided by 3x. So again, I'm going to split these up. And always remember to put that sign here. That sign will always be your second term. Alright, so let's look at these. 27 over 3 is 9. I've got 1x here and I've got 3 there. So I'm going to get rid of this one. I'm going to get rid of one of those, leaving me with 2. 9 over 3 is 3. 1x there, 2 there, so I'm going to get rid of 1 there. I'm going to get rid of 1 there, and I'm left with just 1. And we're done. Okay, let's look at example 4. Divide 15x squared y minus 21xy squared divided by negative 3xy. Okay, so let's split them up. Okay, so let's look at this part of it, and then we'll look at this part of it, and then we'll deal with the sign later. Alright, so 15 over negative 3 is negative 5. I've got 1x here and 2 there, so I'm going to get rid of one of these and get rid of one of those, leaving me with 1. Here I have 1y and 1y, which takes my y's completely away. Leave the minus sign there. 21 divided by negative 3 is negative 7. Whenever I have two negatives side by side, I always put that one in a parenthesis. X over x can disappear. I have 1y there. Get rid of one of those, get rid of one of those, and I'm left with that. So my final answer then is two negatives give me a positive, and I end up with that for an answer. Okay, so let's look at example number 5, and it asks you to divide. I'm just going to cut this off while I'm writing. So there's the problem for example 5, so I'm going to pause again while I split these up. Okay, so there they are split up. So let's look at each one of these terms and cancel what we can. Okay, so the first one here, let me square that out in green. 24 over 8 is 3. So those go away. I've got 2 x's here and 3 up here, so I'm going to cancel 2 of them on the bottom and 2 of them on the top, leaving me 1. I've got 2 there and 1 there, so I'm going to cancel 1 there, cancel 1 there, and I'm left with 1. 16 over 8 is 2. I have 2 there and 2 there, so they both go away. I have 1y here and 2 on top, so I'm going to cancel 1 there and 1 of those, leaving me with 1. Minus, that's what this is, 4 over 8. Okay, so what is 4 over 8? It's 1/2, and then what I like to do is draw that line a little bit longer. Alright, let's look here. I've got 1y here, and I have 2 there. So I'm going to cancel one of those and cancel one of those, leaving me an x on the bottom. So notice, I had 1 on top and 2 on the bottom, so I canceled 1 here with one of these, leaving me 1 on the bottom. Okay, and let's look at our y's. I've got 1 there and 3 here, so if I cancel one of these and one of these, I have 2 on the top. So this whole thing here ends up, well, let's see what we have here. Y squared over 2x. Okay, I could have left my 1 there for 1/2, but it doesn't have to be there. Okay, as long as I've got a 1 up there, or a y, or something up there on the numerator, I don't need to put that 1 up here. If there was nothing up here at all, then yes, I would have to show that there was a 1 up here. But since there is something there, we're good to go. So that is the answer to this division. Now that one was a little tiny bit tricky here. Alright, so let's look at just one more just to give you some final advice on how these work. If I can get rid of all this stuff. Okay, so one of the mistakes a lot of folks make with something like this is they will do that and get x. Okay, remember, this is equal to x over 2 plus 2 over 2. You have to split that 2 up and put it under each part. So then our answer is actually that. Okay, that's the correct way of doing it. So really work at remembering whenever you have pluses or minuses, in fact, let's put it back up here. Whenever you have a plus or a minus on the top, you have to, when you simplify, you have to split these up. X over 2, 2 over 2. When they're multiplied, if this were 2x, you can cancel like that. You don't have to split them up. It's only if there's plus or minuses. So, and again, just another one of those rules that you just kind of learn by doing. Alright, so that was what was called dividing by a monomial. Okay, so when I had a problem like 27x cubed, or x squared minus 4x over 2x, this number here is a monomial. So this section that we just did is division by a monomial, a division by. Remember this by, that word by means draw a line here. Division by a monomial. Alright, so what we're going to do next, and this is where it gets a little bit hairy, is called dividing a polynomial by a polynomial. And in order for you to understand this better, let's do a real basic division problem. You hated these when you were in elementary school. Long division. 27 goes into 3 0 times. 27 goes into 39 1 time. 1 times 27 is 27. Draw a line, subtract. 9 minus 7 is 2. 3 minus 2 is 1. Bring down the 6. 27 goes into 126 4 times. 4 times 7 is 28. Carry the 2. 4 times 2 is 8. Plus this 2 is 10. Subtract. And you get 18. Bring down the 2. Okay. 27 goes into 182 6 times. 6 times 7 is 42. Carry the 4. 6 times 2 is 12. Plus 4 is 16. Giving me an answer of 20 there. Okay. So what we get for an answer is 146 and 20 over 27. Okay, because that ends up, that's our remainder there. Remember when you were really young in elementary school, you'd write 146 R 20. And that was just to kind of give you an idea of what to do with that 20. And as you got older, you realized that, or you were taught that that 20, if you put it over this number, you don't need a remainder. You have a whole number, 146, and 20 over 27 as a fraction. All right, the reason we did that is to get us ready for this next section. So what I'm going to do is I'm going to leave this here. I'm going to stop this video and go to the next video, and we are going to actually divide by a polynomial, and I'm going to leave this example here so that you can refer to it when we're doing these.